So I implemented breadth first search. I used three variables. I used a simple linked list as a queue for nodes to be searched. I used another queue here called state queue. Those are the states of the queues that are actually in the queue for searching to testing for duplicates. I maintain two different data structures preventing duplicates. One is for the tests. One is for the states currently in the queue to be searched, and another for states that have already been searched. As you can see here, when state queue is dequeued, queue itself is also dequeued. This is where it's checked. So this is the main loop line here, is to make sure that state itself has been checked, either again here in the main queue, in this it's already been searched, or here for when it will be searched. This iterator is for the 2 to 4 different successor states. These states are all added are all added. Best first search is very similar, is very similarly maintained to the normal depth first search. The only difference is that the cost is also taken into account. There is an array that sorts the costs and puts them in back of the queue for reverse order. Uniform cost, again, like best first search, similarly maintained to depth first search. Again, it looks at the cost as the heuristic for looking at in which order to add to the queue. A*1 differs from depth first search, uniform cost search, and best first search, in that I maintain states currently, the states of the nodes currently in the queue heuristic value. The heuristic I use is H1, pieces out of place, in addition to the cost. And this is the loop where I test to see either it's already been searched. If it has been searched, see if there's a better possibility that the search we're looking at right now has a smaller cost associated with it, looking at using their heuristic. Otherwise, similar to the method to the algorithms that we'd previously looked at, organizing the newly created states, sorting them and adding them accordingly. A*2 is nearly identical to A*1 in how it looks for in how it tests for old or to be searched states. The only difference is how the heuristic used. It's Manhattan distance as opposed to H1. State is the container class for the individual states. With respect to the successor function here, we go through the entire array to see if the pieces are movable. I implement a function. I use a method called movable, which is simply true or false. Move here creates a new instance of a state. It doesn't actually change the current state. It's then added to an array list called ret, which is then returned into the search algorithm. This is node. It uses state to maintain a parent-child relationship. And the reason this is important is because we need the previous state to know its cost, its depth, its cost and its depth, and its depth through using heuristics. Other methods used are merely peripheral. Get action is understanding which action was used, which action caused the state to change from the previous one. And so that leaves us with the bastard child of the of our search methods, of our search algorithms. Here we have depth first search, which in everything except for these two data structures is the same. It's searched and checked for duplicates the same way as breadth first search is. The only difference is that it's a stack because it's depth first, so we're looking at the first and last out. Down at the main iterator, we see it's essentially the same thing as breadth first search. Its stack is just added, and then after the different stacks are added, we go back and we search the old one, and the stack is just gonna keep getting bigger until the end state is found.